All right, for today's notes, 4.2 day 1, our objective is pretty short and sweet. We are going to be adding polynomials. The objective is short and sweet. The notes take a little bit of time to get through just because we have a lot of definitions today. So to warm up, let's look at these examples. What do you think we need to do on these? They didn't really give us directions, but Tariana, what do you think? Good, we should combine like terms on that first one. What can be combined? Good, the negative 6x and the 8x can be combined together. Negative 6 plus 8 is a positive 2x. Can I then add the 1y to the 2x? No, I cannot. Why not? They're not like terms. They have different variables. What do we think needs to happen first on number 2? Ryan? Good. We need to distribute that negative to every term inside of the parentheses. What does distributing a negative do to our signs? Changes them. So all of them change to the opposite. 3x becomes positive. 10y becomes negative. 9z becomes positive. After we do that, we should check to see if we can combine like terms. Can we? No, none of them are like terms. They all have different variables. Questions, concerns about the warm-ups? Okay, if you can handle those, then you should be able to handle today's problems. But first, let's get through these notes. A monomial is an expression that is a numeral, or just a number, a variable, or the product of a numeral and one or more variables. So when they say numeral, what they really mean, if you want to write yourself a note, is just a number. What we would think of as a number. So let's write down some examples for these. It could just be a number. What's a number? 9. So 9 is an example of a monomial. It could just be a variable. What's a variable? X. It could just be an x. Or it could be a product. What does product mean? Multiplication of a numeral and one or more variables. Okay, so we could put something like 3y. Or we could put something like negative 2abc. All of these are just monomials. Okay? They're all just considered one term. Notice that I don't have any addition or subtraction signs here. I have a negative, but I'm not subtracting it from anything. Right? These are all separated by commas. They're all different terms. So that'll be an important distinction here soon. Those are all monomials. A numeral is called a constant monomial. So if you have just a number, we refer to it as a constant. For example, on the last slide we used a 9. You could have a negative 5. You could have 1,234. Okay, any just plain old number without a variable is called a constant. Questions about constants? Okay. Moving along. A sum of monomials is called a polynomial. So the prefix mono refers to one term. Poly means many, More than one? So more than one term for a polynomial. And they listed a few examples for you. 2x plus 3. 2ab plus b squared. Negative 6x plus 3y plus 12z. All of these have more than one term. You can see the terms broken up by the addition signs in this case. You can also break terms up by the subtraction signs. So on the top example, 2x plus 3, how many terms are in that polynomial? 2. So 1, 2, 2 terms. How many in the second row? Also 2. One big term here, and then another term there. How many terms in the bottom example? 3. So we have negative 6x, 3y, and 12z. You're going to have to be able to count numbers of terms coming up here, I think, on the next slide. Anybody need more time on this slide? Okay, we'll keep it going. So we have some special cases of monomials and polynomials. A binomial has 2 terms. The prefix bi refers to 2, like a bicycle has 2 wheels. Okay, so what would be an example of a binomial? Jakeem? An example of a binomial? Ellie?
3 plus 15.
Close. Let's put like an X on that 3. 3x plus 15. That would be a binomial. If we just had 3 plus 15, we could combine like terms and get down to 1 term. Okay, so we want them to be 2 different terms that cannot be combined. Questions about what a binomial is? They could both have variables, so we could have something like x plus y. We could keep coming up with examples for these all day long. A trinomial has 3 terms. The prefix tri referring to 3. So an example of a trinomial. Anybody have one? We could just take these examples we had before and add something else to them. So if I wrote negative 2y plus 3x plus 15. Now that has 3 different terms all being added together. Or we could have x plus y plus z. Now that one has 3 different terms. Questions about binomials and trinomials? Okay, we're learning a lot of vocab today. Have we heard these words before? Some of them? Like monomial, polynomial, constant. Anybody? A little bit? Okay. More notes. In the monomial negative 3xy, that's 1 term, the numeral negative 3 is called the coefficient, or the numeral coefficient. So the number in front of a term, the number in front of variables is called a coefficient. This last part I think you already know. 2 monomials that are exactly alike or are the same except for their numerical coefficients are called like terms. So we already saw that in the warm-ups. Somebody give me an example of a like terms. 2 like terms. Keon? Sure, 2x plus 3x. Or I'm just going to put 2x and 3x. Those are like terms. What about something that's like negative 3xy? Who can give me a like term for negative 3xy? Ellie? 7xy. Different number coefficient, same variable part. Okay, so even though the variable part was longer, those would still be considered like terms. Anybody needing more time on this slide? A polynomial is simplified, or in simplest form, when no two terms are similar. So we always like to write our polynomials simplified, meaning we've already combined like terms. Okay. Finally, on to some example problems. So our directions say to simplify and classify the polynomial. We always need to simplify before we classify, because it can change if we don't simplify first. Okay, so looking at this right now, how many terms are written on number 1? 3. And we would think that 3 terms would be called a trinomial. But we need to simplify first, because if you wrote trinomial, you would not be correct. What can simplify here? Okay, our x's can be combined. Remember to keep the sign in front of that term with it. So we have to treat the 8x as a negative 8x. 5x minus 8x gives me a negative 3x plus 10y. So now looking at this, how many terms do we have? 2, and 2 terms is a binomial. Make sure you're following the directions. Don't just simplify it, also classify it. Okay, I want you to give the next few examples a try. When you get to number 4, I want you to be careful and remember that x squareds cannot be added to plain x's. Okay, x squareds and plain x's are not the same, so don't try to combine those. We'll go over those answers in just a minute. Who wants to tell me what they got for number 2? Somebody I haven't heard from yet. Danielle?
I got 2 plus 16 and binomial.
2 plus 16m. I like it. You could also write it as 16m plus 2. Either one of those will work. And I agree, it has 2 terms, so it is a binomial. We all get that? Okay, usually you'll see the variable part written first on these. Okay, I won't be picky. Either one of those would be fine. Once you get to Algebra 2, that's when we start getting a little bit pickier about that. Okay? On example 3, Ryan?
3a minus 10b plus 4c and put trinomial.
And good. So when we distribute that negative, it switches all of our signs. Distribute that through, switch the signs. Nothing can combine. There are 3 terms, so it is a trinomial. Okay, who wants to tell me what they got on number 4? May?
Negative 2x squared plus 3x minus 4.
Beautiful. And you classified it as
Trinomial.
a trinomial. So remember, before you got started, I mentioned that x squareds were different from just x's. So we can't combine them. But x squareds can get combined with other x squareds. Negative 3 plus 1. Remember, if there's not a number there, we treat it like it's a 1. That's how we got negative 2x squared. 5x minus 2x is positive 3x. There was nothing to combine with that negative 4. The degree of a monomial is the sum of the degrees of its variables. When they talk about degrees, they're looking at the exponents. So if you want to make a little note to yourself, the degree refers to the exponent. Notice that it's just the exponents on the variables. So any constant coefficients, any plain old numbers, we don't consider their exponents. Ready to keep going? Do we have a couple examples of this? Because I don't know that those are on my slideshow. Let's see. Yeah, those didn't show up in the slideshow. So let's do those examples that you guys have. The first one, 5x squared yz to the 4th. So we just need to determine the degree of it. It is one term, even though there are multiple variables. Okay, one term, lots of variables. To find the degree, we are going to take the sum, which means we add all the exponents on the variables. So what's the exponent on x? 2 plus the exponent on y. On y? With the y, it's a little bit tricky. Do they have an exponent written on the y? No. So we have to know that when there's nothing written there, it's implied to be a 1. Okay, kind of like if we were to just write it as a y, we would consider it to be a 1y. Same thing goes for the exponent. We have to know that it's a 1 even though they don't write it there. So 2 plus 1 plus the exponent on z is a 4. If we add those all up, we get a degree of 7. Okay, questions about that? If we're asked for the degree, we just add up all of the exponents on the variables. That second one, negative 10x cubed y squared z to the 8th. We're adding up the exponents on the variables. So what am I adding together? 3 plus 2 plus 8 gives me 13. So that's the degree on that one. Questions about identifying the degree of a monomial. So that's if we just have one term. That's how we find the degree. Okay? The degree of a polynomial is the greatest of the degrees of its terms after it has been simplified. So if you have a polynomial, you have to find the degree of each monomial in it, each term, and figure out which one is the highest. That's the overall degree of the polynomial. So let's look at this first example. What's the degree of 4x squared? 2, right? We've got an exponent of 2. We don't have any other variables to add to it. Are we okay with a degree of 2 on 4x squared? What do you think the degree is of 5 if there are not any variables? Natalie?
1.
Not 1. 0. There aren't any variables at all. So there are not any exponents for us to add together. Now, which of those is higher? 2. So that's the overall degree of that polynomial. So you figure out the degree of each term and use the highest one. Okay, on the next one, what is the degree of negative 3x to the 4th? 4. What's the degree of 10x cubed y squared? Nope. What do we do with the exponents? We add them. So we get a 5. And what about on 10z? I heard somebody say 0 and somebody say 1. 1, right? That z does have a 1 on it. It's only a 0 if there's not a variable at all. So the highest degree in there is 5. So that's the one that we would use for the polynomial. All right, the next set of examples, they tell us to add and find the degree of each. Technically, we have sort of added polynomials before. We've added equations together, and this is going to be similar. We're just going to put a plus sign there and add down our columns. Okay, because our like terms are already lined up for us. If the like terms aren't lined up, we can't do it this way. We have to rearrange it. But if the like terms are already matched up with each other, we can just go down the columns and combine. So 6x squared plus 3x squared is a 9x squared negative 3xy minus 3xy. Good. Negative 3 plus negative 3 is negative 6xy. What about 2y squared plus y squared? That's a positive 3y squared. Are we okay with adding them together? Adding them together means we are just combining like terms. Now we have to find the degree. So we find the degree of each piece and take the highest. What's the degree of 9x squared? 2. What's the degree of negative 6xy? Good, 2. We would have 1 plus 1. What about 3y squared? 2. What's the highest? 2. They're all the same, right? So by default, 2 is the highest. Deja. So we calculated the degree of each of these. Those are the 2's you're talking about? So in order to decide the degree of the polynomial, we have to know the degree of each piece of it. So this one had a degree of 2 because of the x squared. This one had a degree of 2 because the x and y each have a 1, and we add them together. And then this one, of course, y squared again, has a degree of 2. On number 7, they lined up our like terms for us again, so we are just going to add down our columns. 6a plus 4a is 10a. Negative 4b plus 4b cancels out, so we don't need a b anymore. C plus c is 2c. Are we okay with combining them? All right, what's the degree on 10a? The degree on 2c. So overall, our degree is a 1. Questions on these? Okay, we'll keep it moving. Number 8, we are still adding and classifying, but this one, they did not line up for us. They wrote it out sideways. So they want us to add these together. If you would like, you can rewrite the second one underneath the first one. So that way they are lined up like they were on the first couple examples. Let's see. So should we put anything underneath the 2b? Why not? Not good, not the same variable. So over here we have a plus 9. That does not match up with 2b. So there's nothing to combine with the 2b. If you want, you could put a 0 there. But then I would put the plus 9 towards the end because there's nothing to add to the 9 in this polynomial. Okay, so match up like terms. If there isn't something like it, don't line them up. Make a separate space for it. Does that make sense? The a squared's matched, the ab's match, nothing matched with 2b, nothing matched with the 9. So now we're ready to add our like terms together. 2a squared plus 4a squared. 6a squared. Positive ab minus 3ab. Plus or minus. Good. Negative or minus 2ab. There's nothing to combine with the positive 2b. So I'm just going to write plus 2b. And there's nothing to combine with the positive 9. So we just bring down a plus 9. If there's nothing to combine with it, you can put a 0 if you want. But you don't have to. Questions about adding those? Okay. Then we need to classify it by its degree. What is the degree of 6a squared? 2. The degree of negative 2ab? Also 2. The degree of 2b? And the degree of 9. Good. Overall, our degree would be 2. Natalie?
Where did we get that second 2 from?
This one?
Yes.
So a would have an exponent of 1, and so would b, and we add them together to get the 2. Ryan?
So the answer would be whoever has the most.
Whichever degree is the highest. Okay, so this is our answer for simplifying it or adding them. And then the 2 is our answer for what the degree is. Any questions on this one before we keep going? Okay. All right, let's talk about these together. At least we'll do 9 together and maybe try number 10 on our own. On number 9, do they have all the like terms matched up for us? No. So my recommendation is to rewrite it to match them up. It's not entirely necessary. You can do it another way. Like just go through it and say, is there anything to combine to the 3x cubed? Anything we want to combine with 3x cubed? No, there are no other x cubes. So you can go through and ask yourself one at a time if you want to combine things or just rewrite them. For some of you, my recommendation would be to rewrite the top one and then see if you can match up anything from the bottom one with it. So can we match up 4xy with any of these terms from the first one?
Yes.
What would it match up with? Good. The 4xy would match up with the 2xy. So I'm going to write it underneath the 2xy. Will the minus 5y squared match up with anything from the top one? See a couple people shaking their heads. No, it won't. So I'm going to write it off to the end like I did on that last problem. Will the minus 2 match up with anything? What? Good. The minus 2 would match up with the negative 9, so I write it underneath there. Okay, so if you want to just go through and ask yourself one at a time if there's anything to combine with it, that's fine. I think some of you can handle that. I think some of you would benefit from seeing the like terms lined up one underneath another. Okay, figure out which way is going to work best for you. Now when we add these, is there anything to combine with the 3x cubed? No, there's nothing underneath it. So we just write it down. 2xy plus 4xy is a positive 6xy. Negative 9 minus 2 is negative 11. Is there anything to combine with the negative 5y squared? No. Okay, so this is how we would add them together. Then we have to do the degree. What is the degree of 3x cubed? 3. The degree of 6xy? The degree of 11? And the degree of 5y squared? So overall, our degree is a 3. Questions, concerns about number 9? Okay, I want you to take a minute and try number 10. So for most of you, I would recommend writing it out, rewriting the top one, and matching up terms from the bottom underneath terms from the top. Okay, if it doesn't have something to match up with, just leave it blank, either above or below it. We'll talk about it in a minute. All right, on number 10. What did we get? Is that not enough time to do it? Deja?
What you mean what I do, like the problem or the like?
Yep, when you added them together.
I got 5g4 plus 2g 2h minus 2h2 minus 9.
I think I got lost because you're reading your exponents as numbers, not quite the same way. So what did you get after the 5g to the 4th?
I got 2g to the squared, then I got h.
Okay.
The 2g h squared, then I got 2h squared minus
Is it a positive or negative 2h squared?
negative.
Okay. And then minus 9. So what I put up here, is that what you said?
Yeah.
Okay, good. I would agree with that. So either go through and see if you can combine terms. So we should have combined 7g to the 4th minus 2g to the 4th. We should have combined h squared with the negative 3h squared. And we should have combined the positive 1 with the negative 10. Okay, there was nothing to combine with the 2g squared h. All right, who wants to help me out with my degrees for each term? Keon?
5g is 4.
Okay.
Next one is 3.
Mm-hmm.
Next one is 2.
Okay.
0.
Good. So our degrees were 4, 3, 2, and 0. So our overall degree would be 4. Good. Questions about example 10? I believe we have one more. Are we ready for it? Some of us do it already. Good for you if you did. This one I think is actually easier than the last one. Why? They already lined them up for us. Okay, they already lined up the A's, B's, C's, and then D didn't have anything to line up with it. Okay, so you can put a 0 down there if you would like to. You don't have to. 8a minus 9a. Negative 1a, or just negative a. 10b minus b is a positive 9b. Negative 5c plus 2c is negative 3c. And then on the end we would have plus 6d, because there was nothing to combine with it. What is the degree of each one of these terms? 1. They're all 1s. They each have just one variable, so our overall degree would be a 1.